All right, this is going to be super FRQ number 3. So first off, we get the differential equation dy dx equals xy cubed. And then they give us an initial condition. So the first thing we wanted to do is do a slope field. So for slope fields, remember we just take every single point and we plug it into our slope equation to figure out what the slope would be at that point. So for this particular one, we can see that anytime x equals 0, our slope is going to be 0. So there's 0 slopes there. And also, anytime y is 0, our slope will be 0. So that was an easy way to get rid of 6 of them. Now I'll just plug in the other points. So let's say I have -1, 1. Plug it in. We have dy dx equals -1 times 1 cubed, which equals -1. So I'll just sketch a slope of -1 there. Then I have the point -1, 2. Which gives me -8, so that's going to be a lot more steep. Then I'll plug in 1, 1. Which gives me a slope of 1. One, 2. Would be 8. 2, 1. Is 2. And 2, 2 is 16, so that's the steepest. And then it wants us to sketch a solution curve through the point 0, 1, so we got to make sure it goes through 0, 1, which is this point right here. And I'll just follow whatever my slope looks like. So it's very steep, gets less steep, becomes 0 at this point, and then it becomes steep again. So you just kind of follow the slope field in this case. All right, next we need to say everywhere where it has a horizontal tangent. That means where the slope equals 0. We've already kind of done that because that was my first step when doing the slope field. So it's going to be anywhere x equals 0 or y equals 0. All right, the second derivative equals that. We need to verify it. So I'm going to take the second derivative, using product rule. So product rule is going to be the first times the derivative of the second, which is 3y squared dy dx, plus derivative of the first, which is 1, times y cubed. And then I need to just replace dy dx again. So this is really going to equal x 3y squared times xy cubed plus y cubed. And then I want this to match what it does up here. So I'm going to go ahead and simplify this. This is going to become 3xy squared times xy cubed plus y cubed. Then it simplifies again to give me 3x squared y to the 5th plus y cubed Factor out a y cubed, and I'm left with 3x squared y squared plus 1. Then flip that around, and now it matches. Then it wants to know if we have a point of inflection at this point. So point of inflection should tell us the second derivative equals 0. So I'm going to plug into the second derivative, this point. So my y should be a 2 cubed times 1 plus 3 times 1 squared times 2 squared. I'm going to get 8. 1 plus 4 times 3 is 12. So I get 8 times 13. So we're going to say no, it does not have a point of inflection. At the point 1, 2, because the second derivative does not equal 0. All right, now I'm going to erase all this just so I have room to write. Now D wants to know if we have a relative minimum, relative max, or neither at 1, 2. So the first thing we should check is that for this to even happen, we know the first derivative has to equal 0 in order to have a max or a min. So let's go ahead and plug it into our first derivative, which we know is xy cubed. So at that point, it's going to equal 1 times 2 cubed, which equals 8. So since dy dx equals 8 at 1, 2, there will not be a max or min because it's not a critical point. Okay, E, I need to write the equation of a tangent line at x equals 1. So right away, I'm going to write x equals, y equals, and slope equals. So I know x equals 1, and up here they give us the point. We have the point 1, 2. So I know y is going to equal 2. And then I just found my slope at that point was 8. So my tangent line is going to be y minus 2 equals 8 times x minus 1. So to approximate it, I'll just replace x with 1.5. So y minus 2 equals 8 times 0.5. Y minus 2 equals 4. So y is going to equal 6. This tells me that f of 1.5 is approximately 6. All right, now we need to figure out if this is a underestimate or an overestimate. And essentially this all just depends on if f is increasing or decreasing because it matters about concavity. So concave up, f prime is going to be increasing. Concave down, it's going to be decreasing. So looking at this, we know where 1.5 is. It's going to fall right here. And if you remember, let me redraw kind of what these look like. As we go on, we can see our slope is increasing. And we care about this point because that's the point we approximated. So anytime our slope is increasing, we know that our original function is going to be concave up. And if you draw a line, a tangent line on a concave up function, we can see that it's an underestimate. Because dy dx is increasing at x equals 1.5, so y is concave up. Lastly, I need to find the particular solution to this differential equation. We'll do that using separation of variables. So I should have dy dx equals xy cubed. So I'm going to put these on different sides. So 1 over y cubed dy equals x dx. Take the antiderivative. Remember, this is just y to the negative third power. So when I take the antiderivative, I'm going to get y to the negative second power divided by negative 2 equals x squared over 2 plus c. And then to find c, I'm going to plug in the points that they gave us. But first, I'm going to move that y to the bottom. So it's going to be negative 1 over 2y squared equals x squared over 2 plus c. So if I plug in 1 and 2, I'm going to have negative 1 over 2 times 2 squared equals 1 squared over 2 plus c. So negative 1 over 8 equals, I'm going to change that to, it's more 1/2, so it's going to be 4/8 plus c. Subtract it over, we should get negative 5/8 equals c. So then I have negative 1 over 2y squared equals x squared over 2 minus 5/8. And then we'd really just need to get y by itself. So I'm going to multiply everything here by a negative 2. So I have 1 over y squared equals negative 2 times x squared over 2. It's just negative x squared plus 10 over 8. Then I'm going to multiply by y squared, divide by everything else. So it's going to really end up 1 over negative x squared plus 10 over 8 equals y squared. Then I just square root it. So plus or minus square root of 1 over negative x squared plus 10 over 8 equals y. And then I need to approximate f of 0. That's this next part. So that just means I'll replace the x with 0. So that's going to be y equals plus or minus square root of 1 over negative 0 squared plus 10 over 8. And I'm not even going to try to simplify this. It just equals plus or minus square root of 8/10. So f of 0 is approximately plus or minus square root of 8/10.